July 1st, 1916. 7:28 in the morning. Along a front stretching 25 miles across the chalky fields of northern France, over 100,000 British soldiers crouched in their trenches. They had endured a week of thunderous noise as their artillery pounded German positions. Now, in the final seconds before 0 hour, an eerie silence fell across no man's land. At exactly 7:30 a.m., whistles shrieked along the British line. Officers climbed ladders, revolvers drawn. Soldiers followed, emerging into the summer daylight, carrying 60 pounds of equipment each. They formed lines and began walking toward the German trenches, 600 yards away. Within seconds, the air erupted with machine gun fire. Men fell in waves. Some made it 20 yards. Others collapsed at the parapet. In certain sectors, entire battalions were cut down before they crossed their own wire. By nightfall, 19,240 British soldiers lay dead, and 57,470 had become casualties, making it the worst single day in the history of the British Army. The question that haunted survivors was simple: how? How had German machine gunners survived a bombardment that fired 1.7 million shells over 7 days? How were they able to man their weapons so quickly? How did an attack planned for months by the finest military minds in Britain turn into a massacre? The answer lies not in tactical genius or superior courage, but in something far more mundane: engineering. The Germans had spent 2 years building the most sophisticated defensive system the world had ever seen. To understand why July 1st became a slaughter, we must understand what the British were attacking. This is the story of the Battle of the Somme, but told from a perspective rarely examined in depth: the German preparations that made catastrophe inevitable. When German forces first arrived on the Somme in September 1914, they found themselves occupying high ground overlooking a gentle river valley. The terrain gave them a natural advantage, and they intended to keep it. While the British and French focused on mobile warfare, hoping the stalemate would break, German commanders made a different calculation. They would dig in, fortify, and create defensive positions so strong that no attack could dislodge them without unacceptable casualties. The geology of the Somme region made this possible. Beneath a thin layer of topsoil lay thick deposits of chalk, a material that would prove crucial to German defensive strategy. German dugouts were typically much deeper than Allied positions, usually a minimum of 12 feet deep, and sometimes dug 3 stories down, with concrete staircases to reach the upper levels. The chalk was stable enough to carve extensive underground chambers, yet soft enough to excavate without explosives. It drained naturally, preventing the flooding that plagued trenches cut through clay. Most importantly, it was thick enough to provide protection from even the heaviest shells. German engineers began construction immediately. Infantry battalions rotated between frontline duty and labor details, digging constantly. Some dugouts reached as far as 40 feet underground, equipped with electric lighting, kitchens, and bunk beds. These weren't simple shelters carved into trench walls. They were underground barracks capable of housing entire platoons in relative safety and comfort. Entrance shafts descended vertically or at steep angles, often with multiple exits to prevent troops from being trapped if one entrance collapsed. Wooden beams reinforced the ceilings. In some cases, concrete was poured to create shell-proof chambers. The scale of this construction project was staggering. Along the 25-mile front that would become the Somme battlefield, thousands of these dugouts were carved into the chalk. They were connected by communication trenches that allowed movement between positions without exposing soldiers to fire. Supply dumps were established underground. Aid stations, command posts, even rest areas with furniture salvaged from abandoned French villages, all of it hidden beneath the surface, invisible to British observation. But the dugouts were only one element of the German defensive system. Equally important were the machine gun positions. German doctrine emphasized the MG-08 machine gun as the primary defensive weapon. This water-cooled weapon could fire 400 to 600 rounds per minute, and with proper cooling and ammunition supply could maintain fire almost indefinitely. The Germans positioned these guns with interlocking fields of fire, meaning that any point in no man's land could be targeted by at least 2 guns simultaneously. If attackers overran one position, they would immediately come under fire from another. The guns themselves were protected by reinforced positions. Some were housed in concrete pillboxes with narrow firing slits. Others occupied armored shields. All were positioned to provide maximum coverage of the approaches. German gunners trained relentlessly, practicing the rapid transition from dugout to firing position. They knew that when an attack came, speed would be everything. The gun crews drilled until they could emerge from their shelters, carry their weapons up steep stairs, set them up in firing positions, and open fire in under 90 seconds. Then there was the wire. The defenses included extensive barbed wire barriers positioned in front of the trenches. This wasn't the agricultural fencing wire used on farms. This was military-grade barbed wire, as thick as a man's thumb in places, strung on iron stakes driven deep into the ground. The Germans layered it in belts 30 feet deep. They wove it in complex patterns designed to funnel attackers into killing zones. They placed it far enough from their trenches that even if shells landed directly on the wire, the explosions wouldn't damage the trench parapets. By mid-1916, the German defensive system on the Somme consisted of 3 main lines. The front line held the initial positions, the most heavily fortified and the most likely to bear the brunt of any attack. Behind it, between 2,000 and 4,000 yards back, ran a second defensive line, equally fortified. Further still lay a third line, less developed but still formidable. This defense in depth meant that even if attackers broke through the first line, they would immediately face fresh defenses manned by reserve troops. The system was designed not just to stop attacks, but to grind them down through attrition. German troops occupying these positions lived an underground existence. During the day, observers watched the British lines through periscopes, taking notes on troop movements and defensive preparations. At night, patrols ventured into no man's land to maintain the wire and gather intelligence. When artillery fire intensified, entire companies would retreat to their dugouts, waiting in the chalk darkness while shells exploded overhead. The discipline required was extraordinary. Soldiers had to trust that their shelter would hold, that the tons of earth and chalk above them would absorb the blast. And it did. The deep dugouts proved nearly invulnerable to everything except a direct hit by the largest shells, and even then, the chalk often absorbed enough of the blast to prevent catastrophic collapse. This, then, was what the British faced in the summer of 1916. Not just trenches, but an interconnected fortress system built over 2 years by an army determined to hold every inch of captured ground. The Germans had turned the Somme into a position that could theoretically withstand any assault. The British were about to test that theory. On the British side, Field Marshal Douglas Haig and his staff were planning the largest offensive the British Army had ever attempted. The strategic goal was to relieve pressure on the French at Verdun, where German attacks had created a crisis. The tactical goal was simpler: break through the German lines, exploit the gap with cavalry, and restore mobile warfare. Haig believed this was achievable through a combination of overwhelming artillery fire and properly coordinated infantry assault. The plan relied heavily on artillery. British gunners had assembled over 1,500 guns along the Somme front. For 7 days, from June 24th to July the 1st, these guns would pound the German positions. The bombardment had multiple objectives: destroy the German wire so infantry could advance unimpeded, collapse the dugouts and kill or demoralize the defenders, destroy German artillery positions to prevent counter-battery fire, and create such chaos in the German rear areas that reinforcements couldn't arrive in time. The bombardment began on schedule. 1.7 million shells were fired over 7 days, an average of 1 shell every 4 seconds. The noise was audible across the English Channel. British soldiers waiting in their trenches felt confident. Officers assured them that nothing could survive such a pounding. The phrase, "not even a rat could live," became common. Intelligence officers calculated that German casualties from the bombardment alone would be catastrophic. When 0 hour came, infantry would simply walk across no man's land and occupy the destroyed German trenches. The fatal assumption underlying this entire plan was that artillery could neutralize deep fortifications. British planners knew the Germans had dugouts, but they underestimated their depth and resilience. They assumed that shrapnel shells, which exploded above ground and showered fragments downward, would be effective. They didn't account for the fact that soldiers 30 or 40 feet underground were essentially invulnerable to anything except a direct hit by a high-explosive shell heavy enough to penetrate that depth of chalk. There were other problems. Many of the shells fired during the bombardment were duds. British industry had ramped up production so quickly that quality control suffered. Some estimates suggest that up to German commanders recognized immediately that tanks represent a fundamental challenge to their defensive philosophy. Reports from the front emphasized the need for anti-tank weapons and tactics. In the short term, German artillery would target tanks specifically. Field guns would be repositioned to engage armor at close range. In the long term, specialized anti-tank rifles and guns would be developed. But in September 1916, the Germans had no effective counter. The fortress system that had held for 2 years suddenly had a weakness. The tank attack at Flers-Courcelette didn't break the German lines. Too few tanks participated and too many broke down. But it changed the calculus of defensive warfare. The era when deep trenches, wire and machine guns could stop any attack was ending. The future would belong to combined arms operations, infantry, artillery, aircraft and armor working together. The Germans would have to adapt or face obsolescence. As September turned to October, the weather on the Somme deteriorated. Autumn rains transformed the battlefield into a landscape of mud and water-filled craters. The chalk soil that had been such an advantage for German dugout construction became slippery and treacherous on the surface. Tanks bogged down. Infantry struggled to advance through knee-deep mud. Artillery shells landing in saturated ground often failed to explode properly, their force absorbed by the muck. The battle continued despite the conditions. British commanders, having committed so much already, were reluctant to halt operations without more substantial gains. Each attack now was justified not by the breakthrough that clearly wasn't coming, but by the need to maintain pressure, to wear down German reserves, to capture positions that would serve as jumping-off points for future operations. Beaumont-Hamel, a village that had been an objective on July 1st, finally fell to the British in November. The 51st Highland Division attacked on November the 13th, advancing through a snowstorm. After 5 days of fighting, they occupied the ruins. The cost had been enormous for a village that would have negligible strategic value. But by November 1916, the Battle of the Somme had long since stopped being about strategic objectives. It had become about endurance, about which side would break first under the accumulated weight of casualties and exhaustion. On November 18, 1916, Field Marshal Haig finally called off the offensive. Snow was falling across the battlefield. The ground was frozen. Further attacks would be impossible until spring. The Battle of the Somme, which had begun with such high hopes in July, ended in a winter stalemate. The territorial gains were minimal. The British Empire had suffered 420,000 casualties and the French 200,000 for an advance of 13 kilometers, 8 miles. That's a distance a person could run in under an hour, purchased with over 500,000 British and French casualties. German losses exceeded 440,000 casualties, proving that the defenders had also paid an enormous price. The question of who won the Battle of the Somme has been debated ever since. Tactically, it was a stalemate. The Germans held most of their original positions. The British and French had gained ground, but failed to achieve a breakthrough. Strategically, the picture is more complex. The battle had relieved pressure on Verdun, achieving one of its original objectives. It had cost Germany experienced troops that couldn't be easily replaced. The losses contributed to German decisions in early 1917 to withdraw to the Hindenburg Line, a shorter defensive position further back that would require fewer troops to hold. From the German perspective, the Battle of the Somme was a defensive success purchased at catastrophic cost. Their defensive system had functioned largely as designed. The deep dugouts, the layered defenses, the machine gun positions, all had forced the British to pay an enormous price for every yard of ground. But the casualties couldn't be sustained indefinitely. The German army that emerged from the Somme was different from the one that had entered it. Veteran soldiers who had been the backbone of the defensive system were dead or wounded. Replacements lacked their training and experience. The myth of German invincibility had been damaged. For the British, the Somme was a tragedy that forced the army to evolve. The tactics of July 1st, walking in lines across no man's land toward prepared defenses, were abandoned. Future operations would emphasize artillery preparation that actually destroyed defenses rather than merely attempting to. Infantry tactics became more flexible, with soldiers learning to advance in small groups, using terrain for cover. The coordination between artillery and infantry improved. The lessons were painful and expensive, but they were learned. The legacy of the Battle of the Somme extends far beyond the casualty statistics. The German defensive system that held through the summer of 1916 represented the pinnacle of static defensive warfare. The deep dugouts carved into chalk, the layered defenses, the interlocking fields of machine gun fire, these were refinements of techniques that had developed over 2 years of trench warfare. They proved that given time, resources, and favorable terrain, defending forces could create positions that were extraordinarily difficult to overrun. But the battle also demonstrated the limitations of pure defensive strategy. The German system could blunt attacks and inflict massive casualties, but it couldn't win the war. It could only delay defeat. Every shell fired at German positions, every attack that had to be repulsed, every casualty suffered in defense, all of it wore down the army's strength without offering a path to victory. The Germans were defending occupied territory, and defense alone wouldn't force the Allies to negotiate. The introduction of tanks, primitive as they were in 1916, pointed toward the future. Armored warfare would eventually provide the breakthrough capability that artillery and infantry alone couldn't achieve. German defensive engineering, no matter how sophisticated, couldn't counter vehicles that were immune to small arms fire and could cross trenches. The defensive systems that worked in 1916 would be obsolete by 1918, when tanks would play a crucial role in breaking the stalemate. The human cost of the Somme scarred both nations. In Britain, the battle came to symbolize the futility of modern war, the sacrifice of a generation, the incompetence of commanders sending men to pointless deaths. The PALS battalions, recruited from single communities, meant that entire towns lost their young men in single days of fighting. Memorials across Britain list the names of those who died on the Somme, constant reminders of the price paid. In Germany, the Somme was remembered as a defensive success, but one that demonstrated the unsustainable nature of attrition warfare. The soldiers who survived the battle carried psychological scars from months of bombardment and combat. The German home front, which had been largely insulated from the reality of the war, began to understand the true cost as casualty lists lengthened. The deep dugouts themselves became artifacts of the battle. Some still exist, preserved as historical sites. Visitors can descend into the chalk and see where German soldiers waited out bombardments, where they slept, where they prepared for the attacks they knew were coming. These underground spaces, carved with such effort and maintained with such discipline, stand as monuments to military engineering and to the soldiers who lived and died in them. Modern military historians studying the Somme focus increasingly on the German defensive preparations. The traditional narrative of incompetent British commanders sending men to slaughter is giving way to a more nuanced understanding. The British faced an extraordinarily well-prepared defense. The German system that held on July the 1st represented 2 years of continuous fortification by an army determined to make every position as strong as possible. Breaking through such defenses would have required tactics and technologies that simply didn't exist in 1916. The Battle of the Somme teaches lessons about the interaction between technology, tactics, and terrain. The Germans understood their terrain advantage and exploited it fully, digging into the chalk to create bomb-proof shelters. They deployed their technology, machine guns, artillery, defensive engineering, in ways that maximized their effectiveness. Their tactics emphasized discipline, rapid response, and interlocking fields of fire. The result was a defensive system that could absorb punishment and continue functioning. But the battle also shows the limits of defensive thinking. The German fortress on the Somme held, but it consumed resources and lives at an unsustainable rate. It tied down troops in static positions when maneuver might have offered better options. It created a psychological commitment to holding every yard of ground, even ground with minimal strategic value. The same engineering prowess that created the deep dugouts could have been applied to mobile warfare, but German doctrine in 1916 emphasized defense above all else. On July the 1st, 1916, when British soldiers climbed out of their trenches and walked into machine gun fire, they were attacking more than just enemy soldiers. They were attacking a fortress system built over 2 years, designed by military engineers, constructed by thousands of soldiers, and refined through constant improvement. The deep dugouts that sheltered German troops were technological marvels for their time, requiring understanding of geology, engineering, and construction techniques. The machine gun positions represented sophisticated defensive planning. The wire obstacles were laid with geometric precision. The catastrophe of that first day happened because British planners underestimated what they were facing. They assumed artillery could destroy defenses that were actually designed to survive artillery. They believed the bombardment would kill defenders who were actually safe 30 feet underground. They expected to find cut wire and collapsed trenches, and instead encountered intact obstacles and alert defenders. The German defensive system on the Somme represents one of the most successful applications of military engineering in history. It achieved its purpose, stopping attacks and forcing attackers to pay an enormous price for minimal gains. That it ultimately couldn't prevent German defeat in the war doesn't diminish the achievement of the soldiers and engineers who built it, and the troops who defended it through months of bombardment and assault. Lieutenant Red Cochrane's moment off Guadalcanal in 1943 demonstrated how technology could change warfare instantaneously. The Battle of the Somme demonstrated how engineering and preparation could shape warfare over years. The Germans built a fortress in France, and for 5 months in 1916 it held against everything the British and French could throw at it. The cost of finally breaching it was measured in hundreds of thousands of casualties and changed how armies thought about attack and defense forever. Today, walking the preserved trenches and visiting the museums along the Somme, visitors can see evidence of the German defensive system. Preserved dugout entrances descend into the earth. Concrete machine gun positions still stand, their firing slits oriented toward what was once no man's land. The land itself, scarred by millions of shell impacts, has never fully recovered. The battlefield is a landscape-scale monument to military engineering and the terrible human cost of modern warfare. The soldiers who built the German defenses, who sheltered in the deep dugouts during bombardments, who manned the machine guns on July the 1st, they were doing their duty as they understood it, defending positions they had been ordered to hold. The British soldiers who attacked, knowing the risks, following orders despite the carnage, they too were doing their duty. The Battle of the Somme was tragedy on an industrial scale, a demonstration of what happens when human courage confronts modern technology and engineering in warfare. The fortress the Germans built on the Somme held for 5 months. It cost over 1 million casualties to reduce it, and in the end, the Germans voluntarily abandoned it in early 1917, withdrawing to positions even stronger than the ones they left behind. The Somme had proven that defensive engineering could stop attacks, but it had also proven that such defenses consumed armies, exhausted nations, and ultimately couldn't win wars. The deep dugouts carved into the chalk of northern France stand as monuments to that lesson, underground museums to a way of warfare that reached its apex in 1916 and began its decline in the same year.